In this video, we're going to take a look at how to go from the name to the formula for a ternary ionic compound. So let's go to our handout here. I'm just going to erase a little bit to make some room. So here we have the main steps for for writing the formula for a ternary ionic compound based on the name. And it's essentially the same as you would do for any ionic compound. You just have to be careful with what you do to the polyatomic ion. You need to make sure you don't destroy it in any way. You need to make sure that you preserve the atoms that make it up. So we're going to write the metal first with its charge on top. We're going to put the polyatomic ion next with its charge on top. We're going to do a reverse. We're going to do a crisscross and then reduce if needed. But you never reduce what's inside the bracket. You never reduce the atoms of the polyatomic ion itself, but you can reduce what's outside the brackets. So let's do an example. Let's do calcium chlorate. So calcium is in group 2, so it's 2+. And right away, I'm going to put my polyatomic ion in brackets. So that's ClO3 brackets 1-. And then I'm going to crisscross. I'm not going to touch anything on the inside of the polyatomic ion bracket, of course. Bring this 2 outside the bracket there. Bring this 1 just next to the calcium. And we get Ca1 bracket ClO3 2. We clean it up by putting Ca bracket ClO3 2. So what does this mean? If we're doing a charge balancing, this would essentially mean we have calcium is 2+, ClO3 1-, and we have another one of those ClO3s 1- there. So overall, that's a charge of 0. We have 2 chlorate ions there. So charge balancing or crisscross work. Let's try the next one, potassium hypophosphate. So we have to be careful here. Hypophosphate, PO4 is phosphate. PO4 3- is phosphate. So hypophosphate, phosphate is 1 below that, so PO3 3-. Hypophosphate would be another 1 below that, so PO3 3-. PO2 3-. The charge doesn't change, it stays the same. It's just the number of oxygens changing. So we went from PO4 to PO3 to PO2. So we have K plus 1 or 1+. Open the brackets. PO2, close the brackets. 3-. Crisscross, or you can do charge balancing, and we get K3, open brackets, PO2 1. Because there's a 1 on the outside, you can actually drop the bracket, and you can do K3 PO2. And that's potassium hypophosphate. Let's try the next one. Potassium phosphate. Luckily, we already derived it there. So we have K 1+. Phosphate is PO3 3-. Crisscross. And you get K3 brackets PO3 1. Because there's a 1 there, you can drop that bracket and just put K3 PO3. And now let's do potassium phosphate. So we already know phosphate based on the example above. So K1+, phosphate is PO4 3-. Crisscross, and we get K3 in brackets PO4 1. Because there's a 1 there, we can simply drop the bracket and say K3 PO4, potassium phosphate. Let's try our next one here. Let's do ferric per phosphate. So here we have a classical name, ferric, and what we know is that that's the iron 3+ charge, because ferric is the highest charge of iron. There's either +2 or +3. +3 is the highest. Ic means highest. Per phosphate. So phosphate's PO4. So perphosphate is PO5, and the charge, of course, remains the same as a regular phosphate, 3 minus. If you're good at charge balancing, you'd know that you just need the Fe and the PO5, just one of each, and you're done. But if you don't like charge balancing, let's just circle our charges, crisscross, and we get Fe3, PO5, 3. You need to reduce, but you can't reduce what's in here. You can't reduce what's in that bracket. That protects everything. So reduce what's on the outside. Divide by 3, divide by 3, and we get FePO5. And that there is ferric per phosphate. And so in this video, we learned how to write formulas for ternary ionic compounds when essentially ionic compounds with polyatomic ions. We combined a bunch of our rules when there were multivalent elements. We saw how to derive altered polyatomic ions. And so all of our rules came to an end here. If you want to practice and get a good drill, what you can do is you can go to this video link here, which is also found in your presentation. It's naming 88 ionic compounds. And so I'll show you where that is in the presentation. It's right over here. You play the video, you pause it, and try to name them as fast as you can. And then you can play the video afterwards to check your work. And so you'll start off slow, but then you'll increase your speed quite a bit. And just as a reminder, in the presentation, you can go through examples as video examples as well by clicking on the video links that are there for most of the problems that are there already. It just gives you a different perspective from the perspective that I presented. In the next video, we're going to take a look at how to name a special class of ionic compounds called hydrates.